All right. Well, it's like half the internet's broken. I don't know. Some percentage of the internet is broken. The parts that we need, Bruin learned, is broken. So no view quiz today. Thanks for coming anyway. I hope you still pay attention. And those of you watching at home, still watch the video. I don't know. It's still good. Okay. Let's see. So we'll talk about merging tables. This is an important idea because a lot of times the information you need is spread across multiple tables, right? So you have like kind of your big table that has a lot of the stuff you need, but maybe you also have other information that you need to kind of link up with your table. And so we have to talk about merging our tables together, okay? So in the tidyverse, we've been using dplyr as kind of the package to handle a lot of our data manipulation. And dplyr comes with what we call two-table verbs, functions that will merge two tables together or link them up in different ways. And there's a whole bunch of ways to do this, okay? And so let's see what we have here, okay? When working with multiple data sets, you'll need to combine them to get insights from multiple sources. Okay, so we have mutating joins and filtering joins and set operations. And we'll talk mostly on mutating joins, okay? But I'll also just kind of mention filtering joins and set operations. So mutating joins, this is probably the most common thing that you'll do. You have kind of like a big table with a bunch of stuff, but then you also have references to other kind of pieces of information, and you want to kind of pull that information as well. So, well, I'll show you examples of that, okay? Filtering joins are things like you have the kind of the table you're working with, and then you also have another table, and based on what's in the other table, you want to kind of filter down this primary table that you're working with based on the rows that are in the other table or not. Okay, so those are filtering joins, right? So we have filter operations that will say, like, from the table that you're working with, look at the row and say, like, okay, if the age is over this number, we want to kind of filter that, right? But you might not have a single criteria in kind of the primary table you're working with, but you have like a different table. It's like, I don't know, maybe you have, like if you're running some customer management thing, and you might have like, okay, these people are no longer eligible for the promotion because they can't get a free trial because they signed up. They already got their free trial like earlier this year, right? So yeah, a lot of sites will be like, oh, get a free trial of whatever, Netflix or Hulu or whatever for a few days, but then there's a limit. You can't do that for more than once a year or something. And so they might have a table of everybody who's already gotten their free trials, okay? And so you would filter this table based on what's in the other table. Those are filtering joins, okay? Set operations, kind of like mathematical sets where you have intersections and unions and stuff like that, okay? A lot of this stuff was influenced by SQL. And so if you're familiar with that, then a lot of this will look very familiar. And if you've never seen SQL, then great, because now you're going to learn this stuff. And then if you ever have to learn SQL, you'll be like, oh, I've seen a lot of this kind of stuff already. So it goes my way. Sorry. Lots of documentation. All right. Some vocabulary. This is a lot of times in industry, these are some of the terms that we use. We have something called the fact table, and we generally enhance the fact table with the dimension table. So the fact table will be like the big table that you're kind of working with. And so, for example, you can think of like in our flights database, the flights table has, like hundreds of thousands of rows, all with these different flights, okay? And then you have these smaller tables that we might call the dimension tables. These are like our lookup tables, or they provide labels. So for example, in the flights table, one of the columns is carrier, and it'll be something like AA and UA and WN or something like that, right? And those correspond. AA corresponds to American Airlines. UA corresponds to United Airlines. I think WN is Southwest and things like that. And so that information is stored in a separate table where it says, okay, AA stands for American Airlines. UA stands for United Airlines, stuff like that. So that's going to be stored in a dimension table. There's going to be another table called airports that in the flights table, it just uses a code, right? This is going from LAX to EWR, okay? The other table will say, oh, LAX, that stands for Los Angeles International Airport. EWR stands for Newark Liberty something. I don't know. It's the thing in New York, right? Or New Jersey, okay? And then, you have ORD for Chicago O'Hare and stuff like that. And so that information is in another table. And so basically, you have kind of the big table you're working with. We call that the facts table. It's got these little like codes. And you say, well, what does that code represent? You look that up in the dimension table. Okay, that's not always how this situation works, but a lot of times you have situations like that where you have kind of like labels for these things because the information is stored as these things. And you might wonder, like, why do we write LAX in the thing? Why don't we just write Los Angeles International Airport, okay? Or something like that in the facts table, right? Well, a few things is as far as a data storage perspective, okay, LAX takes up less data space than writing out Los Angeles International Airport. And then the other thing is, for example, this school is UCLA, right? And so I think it makes better sense to just call it UCLA because how have you written out, if you ask, okay, how have you written out your school's name on your resume? There's probably a whole, like 20 different ways to write University of California, Los Angeles, right? Is it University of California, comma, Los Angeles? Is it UC, Los Angeles, University of California, colon, or dash, Los Angeles? University of California, Los Angeles, parentheses, UCLA, and like, how have you written this out? There's going to be like a whole bunch of ways for this to be written out. And if somebody has to enter that data, you're going to introduce a whole bunch of like mismatches when there shouldn't be a mismatch. So what you have is you just say, okay, write UCLA. That's simple enough. And then we have another table that says UCLA corresponds to University of California, Los Angeles. And this is the one and only one way we're going to accept the spelling of it, okay? And that's going to be stored in this other table. So you have a lookup table, and so you don't have to worry about, oh, did I write my thing out a little bit different from your thing, and stuff like that, okay? And so in the dimension table, the thing that you're looking up, usually like the code, like LAX or UCLA or whatever, that's going to be unique. You don't want to have two entries of UCLA in your dimension table that says like UCLA means this or UCLA means, I don't know, is there another is there some other school out there that could have similar UC, huh? L? University College. No, but I mean, okay. I mean, there's not like University of Connecticut, learning annex or something. You wouldn't want something like that, okay? Because you want that unique. But we call this the foreign key in the facts table. Okay, so the facts table, it's fine. You have a whole bunch of flights originating at EWR, right? That's fine. Okay, so you have it repeats a bunch of times in different locations, but then each of those point to the same thing. Okay, so start from the table you want rows from. This is going to be your fact table. Join in what you need. Okay. All right. Just to kind of illustrate these examples, we're going to use these very, very, very small toy data tables to kind of illustrate what's going on. And all of these things will just generalize to a much bigger version. Okay. So I have the people table and I have the states table. And so we have Adam, Betty, Carl, and Doug, and they come from CA, NYTX. And then I have a states table, a very incomplete states table. And we have the abbreviation and the state name. So CA corresponds to California, NY corresponds to New York, WA corresponds to Washington. Okay, so if these are my two tables, we will start off by doing a left join. Okay, and a left join says, so remember I'm piping this in. So you can do left join people comma states, but I often use the pipe, so it'll be like pipe people left join states. Okay, so people is on the left hand side of the join statement, so that's the left join means take the left hand table and use that as your data table, the primary table, and join in what you need. So we're going to basically say I want to take these rows from the people table and I want to join in the information from the states table. So basically, you know, imagine you're from someplace and you're not familiar with the state abbreviations, and you just want to kind of have these things spelled out. So what does CA correspond to? That corresponds to California. And so we just say, hey, people left join with the states table, okay? And then how are we linking it up? You say, look at this column, the column state, and match that up with the column abbreviation. So we're going to say by, and we use this join by operation, and we say join by state equals abbreviation. It says basically take the state column, join it to the abbreviation column, and then join that information together. So we get CA gets California, NY gets New York, okay? TX, there's no entry that corresponds to TX here, so it pulls an NA, okay? And that's the left join, okay? We have something called a right join. Right joins are generally not recommended, but let me just kind of illustrate how this works. So we have people right join states. The right join says, hey, keep everything in the states table and then find matches in the people table. Okay, so start with the right-hand side table and find matches in the left-hand side table. So here, we're going to say join by state equals abbreviation. So same kind of idea here. And so we say, okay, CA is California, and we're going to get Adam. CA is California, and that's going to get Betty. And then we have NY gets Carl. And WA has no match over here, so we get an NA. Okay. And then Doug from Texas doesn't get pulled at all because we're using the states table as kind of our starting point. Okay. Yeah, question.
Is it okay to write drawn by abbreviation equal state?
So no. So for this thing with the right join, okay, so it's always you have a left table and a right table, okay? And so because the left table has state has to go on the left, and abbreviations on the right, abbreviation has to go on the right. So it has to be state equals abbreviation. You have a question? Yes.
Why in both the left join and the right join, the first value is states? Like, shouldn't it switch to the other table?
So yeah, this is why we don't like right joins. But again, it's people join. So think of this as people join states. Okay, people join with states, but which table acts as our fact table, the base that we're going to keep everything from? Okay, in this case, the right join says keep everything in the right table. Okay, and because it's people join with states, people's on the left, so it's going to be state equals abbreviation.
I mean, like the first, right? Like.
Well, why is it name state name or?
Like it's left join then parentheses states and then right join parentheses states.
Mm-hmm.
I think if I understand the question, it's like why is the order of the parameters the same? Like people then states, but I think it's
yeah. So here, let me contrast. Let me do the next slide, and then we can kind of compare all three slides. All right, and I hope this will clear it up. Okay, so right join exists, but you're going to say in general we recommend only using left join because I think this is just how our brains work, and we like left joins. So if you want to, generally, if you want, like, I want to keep everything in states and I want to add things from people, we would say do states left join people. Okay, and so states left join people. States goes on the left. Okay, and we're still joining. We want CA to match with CA. This time, because it's states left join people, and the states table has the abbreviation, it's going to be abbreviation equals state here. Okay, so I think look at this, and I think this makes sense. So we have people left join states. People, we want the state to match abbreviation, so we do join by state equals abbreviation. Here we're keeping everything on the left table. We're joining in everything. We join matches from the right, so we don't get a match for TX. Okay, 2 slides later, I've got left join. We're going to states on the left side. We're going to left join it with people. Okay, this time, because states is on the left, we're going to do abbreviation equals state. We're going to keep everything in the states table, and we're going to pull matches from the people table. So we're going to get California, and then we get a Adam, California, Betty. We get New York, Carl, WA, Washington has no match in the people table, so it gets a NA for this. Okay, is that okay? But if for whatever reason you wanted to basically get the same rows, but you wanted to kind of keep the order of name, state, state name. Okay, over here you'll notice it's abbreviation state name because we're using states table as a base. Okay, so the column names end up being abbreviation state name. Okay, if you wanted it the other way, okay, where this is the base and we're joining in stuff from over as far as like the column names go, then you could do it this way. And so you end up getting the same rows, but the names get pulled from the left table. It's a little weird, right? I include right join for completeness, but I don't know. Maybe I should just skip it and just say only use left joins and switch the order when you need to switch the order. That's generally what we recommend, okay? But do right joins exist? They do. This is how they work. It's a little, I would say, our brains, we're, at least English readers, we're accustomed to reading left to right. And so we prefer left joins. Start on the left, add things to the right. The right join, I don't know. Maybe people who read right to left, maybe this makes a little bit more sense. I'm not sure. But this kind of works in a backwards way, right? It's like 4 and 20 instead of 24, and people, that works too. but anyway, that's the left join and the right join. Okay. The inner join basically says only things that are in common. Okay. And now so we're going to do people and states and only things that have matches. So we're only going to, because CA and NY are the only things that match, we're only going to get Adam, Betty, Carl, CA, California, NY, New York. Nothing for Doug in Texas, nothing for WA in Washington. Okay, that's the inner join, basically the intersection only. Okay, so no NAs over here. And then you have kind of the union, and this is known as full join. Okay, full join, people with states. It says basically keep all of the rows from people, match everything up, and then keep all of the rows from states. So you're going to get Adam, CA, California, Betty, CA, California, Carl, NY, New York, Doug, TX, missing, and then missing WA, Washington. So the full join is basically the union, and anything that doesn't have a match, that gets filled in with NAs. Okay, so just make sure you understand this. I would say these slides so skip the right join, okay? Make sure you understand left join, inner join, and full join, all right? And if you get that, great, because that's pretty much how we're gonna be doing everything. And everything kind of builds off of that, okay? Because if you wanna join like 3 tables together, usually you just do a whole bunch of left joins. You'll say start with this thing, left join this additional thing, okay? And now you imagine I got a bigger table. And then you say left join with another table, right? And now you get an even bigger table and things like that. So that is left join, inner join, full join, okay? We have these different ways to kind of join things. So far you've been seeing join by x equals y. And this is when the 2 tables have differing names. You have state over here, and we have abbreviation. So we had to say join by state equals abbreviation, okay? And it's always kind of the left table with the right table, the left table name, column name, the right table column name. State equals abbreviation. Sometimes it's easier. You just have the same column name on the left table and the same column name on the right table. And you can just do join by x. This join by function, I don't want to say it's not always required, okay? So if you read someone else's code, you might just see by equals x, okay? And not by equals join by x, all right? And you might also see a slightly different format where it's like by equals and then you have a vector x equals y or something like that. This is the preferred or recommended method. It's a little bit additional typing, join by x versus just by equals x, by equals join by x. It's a little additional typing, but it's a little bit more explicit, and it allows for more complicated joins, which I have one example of that later on. Okay. If you leave the by argument blank, the tidyverse dplyr is going to try to figure it out on its own. It's going to do its best. It's going to say, all right, I'm looking at this table and we've got these columns, and I'm looking at this table and we've got these columns. So I'm going to try to assume we're going to look at the matching columns and I'm going to try to match them up, okay? It's got kind of a system that tries to do its best guess. A lot of times it does okay, but sometimes it gets it wrong. So we almost always recommend that you specify the by, okay? All right, sometimes you get what we might call a Cartesian explosion or a Cartesian product. And that sounds bad. And in general, it is, okay? This is what happens if the primary key in the dimension table, is that the word I called it? I think that was the word I called it. Yeah, the primary key in the dimension table is not unique. So here I've got the same people table: Adam, Betty, Carl, Doug, CA, NYTX, okay? And then I have not a states table, but I've got places, okay? But I called it state name, all right? So we have CA, NY, WA, CA for California, NY for New York, WA for Washington. But what if we had a CA for Canada, okay? This would be terrible, all right? We don't want that, where we have 2 things that CA could represent. How does Canada abbreviate itself? It's usually CAN, right? But is there a 2-letter abbreviation? CA? They use CA also? Okay, so yeah, so this would run into a problem of like, okay, if you CA, is that California, is that Canada? There's ambiguity, and so now we have to figure this out, okay? Well, so, the computer doesn't know, all right? Or at least not this, okay? I mean, maybe ChatGPT knows, but here it's just going to do what we call a Cartesian product, and this has the effect of generally creating like a whole bunch more rows. And so basically, it's going to match every instance of CA here with every instance of CA over there. Okay, so if you do a left join here, you're going to get Adam CA California, Adam CA Canada, Betty CA California, Betty CA Canada. Okay, and so you can see now we end up getting more rows than we probably anticipated. And so here I've got basically 2 instances of CA over here and 2 instances of CA over here. So I end up getting 4 rows. But if you had, your facts table probably much bigger, maybe thousands of rows, okay? And maybe your dimensions table, maybe you have 3 instances of CA. You got California, Canada. Was there another CA out there? Something else, okay? And then everything would get multiplied by 3, right? And so you end up getting, going from, you're expecting like 900 matches, now you get like 2,700 matches, right? So this is why we call them Cartesian explosions, because basically you're getting like every, this has to match with that, and that matches with that, and that matches with that, and then this matches with that, So you end up getting a whole bunch of things. So it's important that if you have a dimension table like this, that everything is unique, okay? You don't want CA to be ambiguous. You want CA to be clear. This represents California, and we have a different code for Canada, okay? It's kind of like, like, can you imagine an airport code, right? Like, if you travel to, if you say, I want to fly to New York, okay? There's 3 big airports in New York. There's LaGuardia, JFK, and Newark. And you can't just say, I want to fly to New York, right? You got to pick a specific airport, right? Otherwise we run into problems, okay? And so you don't specify your flight by just saying Los Angeles to New York. You have to specify, JFK or, whatever it is. Okay. So, what do? You have to deduplicate, okay? So you can do something like to try to make sure your places table only has one thing. You call distinct on the abbreviation or whatever you want, okay? Dot keep all true is going to make sure you keep all of the other columns and not just that column. If you just do distinct abbreviation, you're only going to get the abbreviation and you'll lose all of the other information. So you want to make sure you do dot keep all, okay? Now, in the alphabet, California comes before Canada in alphabetical order. So California ends up getting kept here, okay? Obviously, it's a problem if you actually need to have Canada in your thing. And it's usually, if it comes to this point in your data pipeline, something has gone seriously wrong and you blame your data engineers for setting up a bad system here. But if it's ambiguous, where I need to have California and I need to have Canada, but we have CA referencing both of these things, that's a problem, right? It's like 2 people having the same social security number. There are instances of this happening, and it's a problem when these people have to, you want your ID, whatever you're supposed to have an ID, to be a unique thing, okay? And so anyway, deduplicate. That's how you kind of try to fix this stuff. Oof. All right. Let's talk about filtering joins. So this is if you have a table and you have another table, and based on the other table, you either want to keep only those rows in the other table, or you want to get rid of those rows. So you have the semi-join, okay? And it's kind of like inner join, all right? It's just, so inner join looks at table X, looks at table Y, and only keeps the ones that have matches, okay? But with the inner join, if there's additional columns in Y, it's going to join them all in there, okay? It adds them all right? And the semi-join doesn't add any of the columns from Y. It basically uses Y as a way to filter down to X. So it's kind of like, all right, this is, I don't know, I've got the table of all voters, okay? And then I have another table that says these are people in this political party, and we want to send a mailer to just these people in this party. So you use a semi-join there and just keep those things, okay? The anti-join is kind of the opposite, right? You just say, hey, I've got the big table here. These are all of the all of the customers. Why is everybody who's no longer eligible for this promotion? Okay, you do an anti-join, and it basically gets rid of the rows. Okay, and so here I have people and states. So here the only ones that have matches with the states were CA and NY, so we just keep those rows. So again, kind of like the inner join, but we don't add the columns from the other thing. Okay, and then the anti-join says, okay, from people, who was in my people table that didn't have any matches in the states table, and that's going to be Doug from TX. Okay, states with no match. So that's the anti-join. Okay, you have these other things, set operations. So I don't know how often you use something like this, but they exist. Okay, so here I'm just making up two tables. I got CAORWA for West Coast, California, Oregon, Washington, and then I got people states, CANYTX. All right, what's the intersection? The only thing in common is CA. All right, and then you have the difference, okay, which is basically things that are for people states and West Coast. You look at the people states and you say, hey, what's in people states that's not in West Coast? That's going to be NY and TX, okay? And then you have union, and you have that, okay? So I guess set diff is this part, right? So that's set diff, and then the intersect is this is the intersect. This is set diff, and then everything is the union. Okay. All right, so let's do some examples with NYC flights. All right, so again, you have the big flights table, 435,000 rows. We have different things like the carrier, and these are just 2-letter codes for United Airlines, Delta, I don't remember. I think B6 is JetBlue. Okay, AA, American Airlines, stuff like that. Okay, and then you have origin and destination airports, right? So EWR, JFK for the New York airports, and then they're flying to different places. And so if you look at the airlines table, these are different airlines. So you have, American Airlines, Alaska Airlines, JetBlue, and things like that. Okay. All right. And then you look at the airports, and you have the FAA code, and this is, I didn't know there were this many airports, but yeah, okay. California Redwood Coast Humboldt County Airport. Okay, so that's ACV and ACY, and all right, Kodiak Airport. Yeah, who got these? Yeah. Anyway, so we have that. I think there's a video on the internet talking about airport codes. And so anyway, let's say we wanted to take our flights table and we wanted the name of the airline. I'm like blanking out here. All right, so flights would be our fact table. Airlines is our dimension table. So we do flights. We want to join in information from there. How are we doing that? We just do join by carrier, okay? Because carrier is this code, and that column matches the carrier over here. So I don't have to do carrier equals carrier. You just say join by carrier. And then again, sometimes you might just see by equals quote unquote carrier, and that also works. And then here I'm just selecting some of the columns, carrier and carrier name, right? And I don't know, is this how they spell airlines? Why is there a space here and no space here? I don't know. Okay. American Airlines Inc., United Air Space Lines Inc. Okay, well anyway. Sometimes you want to have like summary things, right? So you want to say like, okay, how many total airlines are there? Okay. Republic Airline, you might like, who's Republic Airline? I think they're like a local airline that does if you fly with American Airlines or United Airlines, but it's like a regional carrier, it'll be like United Express and American Eagle and stuff like that. And so anyway, so you have this, and so here we're going to say group by carrier, I want the counts. I want to know how many flights does YX have and how many flights does UA have and stuff like that. Arrange in descending order by counts. And now I want to figure out what is the name, what's the actual airline associated with B6 or DL or 90 or things like that. And then so I do the left join there, okay? So I want to do the summarize, and then I want to add in this information, okay? If you do it the other way and you say, hey, let's do the left join and then group by and summarize, look what happens here, okay? So when you do a group by carrier and then to summarize, that operation is only going to keep the carrier column and then the resulting summary columns, which is just going to be YX and the counts. And so even though the table coming into airline, coming in before this summarize operation had all of these columns, it looks something like this. Remember, when you do summarize, it's just going to say, hey, I don't care about all of these other columns, okay? We don't have the month column or the date column or the whatever, okay? It just says, all right, all I need to know is look at the carrier. We're looking at that. We're going to just count how many rows there are. That's what the count equals n is. And just says that. And so you lose that column that had the airline names, okay? So so here you just get this. So if you want the airline names, you do that. So so if you want to add labels to something, summarize first and then join, okay? When would you do the join first and then summarize? That's if you're using the join operation as a way to filter the rows to keep. So when you're doing something like an inner join or a semi-join or an anti-join to figure out which rows to keep, do that first and then call the summarize operation. Okay. What if we wanted to have information about the airline and also the name of the destination airport? Okay, so so we can join that. We have two dimension tables here. We have the flights table. We want to join in the airline name, and I also want to join in the airport name. Okay, so basically think of this. What's the result of flights left join airlines? It's going to be the flights table plus the airline name column. Okay, and so now that's a new table. Okay, and then I want to add more information. So I'm going to left join the airports. So now I'm going to have destination equals FAA code. And so that joins that in. Okay. The unfortunate thing is if you look at these tables, for the airlines table, we have the carrier and the name. And then for the airport table, I have FAA code and name, right? So now I have these two columns called name, right? So so when we look at the resulting table, and I'm just kind of trying to pick the relevant columns, so it's like this flight. So we've got carrier, UA is United Airlines, and we have destination, SMF is Sacramento International, and DL for Delta and ATL for Atlanta. Because I have name, two columns of name, dplyr automatically just tries to distinguish them and just appends a .x, name.x, and a name.y so that you don't end up having the same exact name, okay? We can control that a little bit. We can have like better suffixes, okay? And so when you know you're going to end up with this conflict here, you say the suffix, we'll put in, instead of .x and .y, we'll put in underscore carrier and an underscore dest, or whatever you want to call it. Okay, so again, first we're joining the flight table with the airlines table, and we end up getting a column called name, and this is name of the carrier. And then I'm going to take that resulting table, which has the airline name, and I'm left joining it with the airports table. And that also has a column called name. And so we're going to do underscore destination. This is optional. Keep equals true, I would say recommended, but what that's going to do is going to keep the join keys from both sides. But you can get rid of it. And so now instead of name X and name Y, we have name underscore carrier and name underscore dest. Okay, destination. So this is probably a little bit more meaningful as far as this goes. Okay, and so we have that. All right, and so that's most of the things. When you do a join things, to avoid the Cartesian explosions, to join some of these problems, we have a few kind of like diagnostic tests that you should try to test out. Or if you notice something's a little bit off, it's worthwhile checking this to kind of make sure you're not going to run into problems. Okay, so one is you want to make sure that in your dimension table, the one like the airlines table where you're going to be joining, you're using the labels to add, or you're trying to add labels to the thing, you want to make sure all of your keys are unique. Okay, so here we're going to say, look at the airlines table. The key that we're using is the carrier column. Okay, so we do count on the carrier. That's going to tell you how many there are. And we want to make sure there's only one, right? We want to make sure there's only one CA, there's only one LAX, there's only one of these things. So you do count on carrier, filter to anything greater than one, okay? And what you want to see is 0. You want to see 0 rows, okay? A table of 0 rows, that means everything is unique. If you have duplicates in here, then you'll get, CA shows up as California and Canada or something like that, okay? So this is what you want. Here, if you, this is to try to make sure you don't have anything that's unmatched. So remember in our people table, we had TX and there was no match in the states table. So like Doug and TX always kind of pulled up NA, all right? This is a check before you do like a left join or something like that. You can run an anti-join and just say, hey, do I have anything over here, right? Are there anything in the flights table that doesn't exist in the airlines table? Okay, so here we're going to say, hey, take flights, take that carrier column, okay? So just look at the distinct unique carriers there, and is there anything over here that doesn't exist over here, right? If you have nothing, if you have 0, that means everything in the flights table has a match, at least for this carrier column, has a match in the airlines table. So that's a good sign, right? If you have things that aren't matching, it'll say, hey, these things don't have matches, okay? This is again just to kind of make sure you're not going to run into any Cartesian explosions here, all right? And so basically you want to make sure this has no duplicates, and over here you're expecting the duplicates, right? So here it's like for the flights table, we're not expecting destinations to be unique. So this is like, I think Albuquerque. There's 228 flights to Albuquerque. Is that right? Okay. ACK, I don't know where that is. 20 flights? This is weird. 20 flights for the entire year? That's like a very seasonal flight. Where is AGS? what airport is that? Okay. And then Albuquerque is like what, 5 flights a week? That seems kind of low. But anyway, that's direct flights from New York to Albuquerque. All right, so we have that. Okay, and then this one is, what if you wanted to have like a very complicated joining thing, all right? And this is what we would call a composite key. And this is where you can say joined by a whole bunch of different kind of columns. And so there is a table called weather. And it was like at JFK Airport on January 1st at 6 a.m. This was the temperature and wind, okay? And then at 7 a.m. this was the temperature and wind, okay? And then also at LaGuardia Airport at January 1st at 6 a.m. this was the temperature and wind, and this is at 7 a.m. this was the temperature and wind. And so how do we match things up like that, right? So each row is basically a location and an hour. So that's there's a whole bunch of things, and we don't want to just say, like, if I did join up on day or join up on location only, we would have a Cartesian explosion, right? Because I would have like thousands of entries for JFK, or Even for the day, I would probably have 24 entries on that. Okay, so in order to make sure everything is unique, I have to specify the location, the date, and the time, okay, or the hour. And so we're going to say join by this and this, year, month, day, hour. Okay, and now I can have a thing, and we can say, hey, I want the month, day, hour, the origin, destination, carrier. I mean, that's extra information, but I want the temperature and the wind speed. So we could say, January 1st at 5 in the morning, 53 degrees, wind speed 4.6. At 5 in the morning at JFK, I don't know what this is. I guess we have different, okay, so we still have a whole bunch of flights, but it's just basically like what were the conditions, okay, of that flight taking off, right? Time and wind, temperature and wind speed at that thing. So we have that. Okay, let's see. All right, I think that's about it. All right, recommended best practices. Yeah, always explicitly do the by and join by statement. Like, it's true. You can be a little bit lazy sometimes and not type this in, and you might get away with it, okay? But best practice, always specify it explicitly. It'll also just make it easier for you to read later, because when you're reading and if you don't remember the contents of every single table, which you probably won't, if you step away from your project and come back 2 weeks later, you're not going to remember the contents of every single table. But by having a by statement and seeing like which columns are being joined, like that gives you an idea of how it goes. Okay. Always check for kind of duplicate keys or missing keys before you do the join, so you don't end up with a Cartesian explosion or you don't end up with a whole bunch of NAs. Okay. And then if you do have duplicated column names, you want to use this suffix thing so you don't end up with name.x, name.y, which is, again, this is all for your own benefit, because later on, trying to remember, was it name.x or name.y? That's hard to remember, okay? Name_carrier, it's very clear what that represents, okay? So all of these best practices are so you have an easier time reading your own code later versus trying to remember everything. So that's it. Okay, hopefully the internet comes back up and I can upload these notes for you guys, and no view quiz today. So that's it. All right, we'll see you guys on Wednesday.